Let's talk about how to perform lost procedures and the diversion. So, you're lost, not sure where you are. Let's figure out what you do first. Here are your lost procedures. First, you're going to want to circle around a prominent point. Second, conserve your fuel. Pull your power down to 2,000 RPM. 3. Cross-check and calibrate your instruments. You're going to cross-check your position and recalibrate your instruments. Fourth, climb if you need to get a better view or to get better reception. And last but not least, if you still can't figure out where you are, communicate with someone. Find the local ATC, perhaps go to the emergency frequency of 121.5 if you have to, or you can talk to Flight Watch and get an update on the weather on 122.0. One way to remember your lost procedures is to circle around your conservation land, cross the path that you think you're on, climb up the highest hill, and then communicate from the top. Number 1, circle. You want to circle around a prominent point on the ground, something like this soccer field that's easy to see. So when you make your nice shallow bank or standard rate turn around this field, you can always keep an eye on it so that you don't lose your location. Remember, as you circle and you do your computations, always look out for other traffic. So, lost procedures. You're going to circle with a shallow bank and standard rate turn and continue looking for traffic. Stay in your location. Next, conserve your fuel. Go ahead and pull back your power to 2,000 RPM. Now it's time to cross-check our position. Let's say we know we are around this general area on our trip from Hanscom Field to Rutland, Vermont, and this is about where we think we are. Well, now we have a general location so we can cross-check our position with some VORs. So now we're going to cross-check our position with some local or nearby nav aids to our general area. Also, I want you to recalibrate your heading indicator. Always make sure that your heading indicator is in line with your compass. Technically, you should be doing that about every 15 minutes. Don't trust your heading indicator. Always check it with your compass. So, we know this is our general location. Let's try to find a VOR maybe about 10 or more miles away and fairly nearby, nothing like 50 miles out. Here is a VOR, you can see from the azimuth, and here we have a VOR as well, as you can see. Looks like a compass rose. The center of the VOR is right here, and at Rutland it's actually on the field. That's why you see a dot on the airport field. If you find a VOR that's too close to your position, let's say we're here where the arrow's pointing, and we know the VOR is just might be fairly close nearby, you could get possibly an erratic reading, or it could fluctuate quite often. That might not be a good reliable source. Sometimes you have to play that by trial and error. Another thing to think about when considering which VOR to choose, think about your altitude. VOR is based on line of sight. So make sure you have ample altitude to get a good reception. So in this case, since I know I'm in this general location, I'm going to use the Rutland VOR, which is situated here, and the identifier is up here in this corner. I'm going to also use the Lebanon VOR, and the identifier is up here in the corner. Okay, let's say this VOR is tuned to the Lebanon VOR. Well, we're going to turn the OBS until we get the needled centered and the from indication. Once we get those things lined up, great. We now have a radial from the Lebanon station, which is 255 degrees. Let's do the same thing for VOR2. We turn the OBS knob, we get the needle centered with the from arrow, and now our radial from Rutland is 165 degrees. Remember, when you do this and you're looking for your position, always center the needle with the from indication and read the top heading away from the station. Now you're going to draw a line along the radial that we just figured out from the VOR. So from Rutland, our radial was 165 degrees. We'll start at the center of the VOR and use a straight edge to draw a straight line through 165 on the azimuth. Next, from Lebanon VOR, our heading away from the station, or you could call it the radial from the station, it was 255 degrees. You can draw a straight edge from the center through 255 and continue that straight line until you intersect that from Rutland VOR. Now we know generally where we are. Actually, we know specifically where we are based on the VORs. Once you get this location, look around. Make sure that it makes sense. You should be able to see prominent features on the map that make sense to your general location that you just figured out. If you did not get a good reading on your VORs, or you're not getting good reception, or you're just having trouble in general figuring out where you are, it's a good idea to climb next. The higher you go, the more you can see and figure out where you are in relationship to the features on your map. If you still get up there and can't figure out where you are, it might be a good time to get some help. You can either contact a local ATC, you can contact emergency frequency on 121.5, and you might want to contact Flight Watch on 122.0 because they're the ones who will give you an update on the weather situation. Okay, now we're going to set up the worst case scenario. Let's say that you fly into instrument conditions by accident and you have low visibility or no visibility. You need to get out of it as soon as possible. So here's what you do. Immediately look down at your instruments and fly by reference to instruments only. Make a 180 standard rate level turn. And remember that as you change your course direction, this might mean you're flying a new altitude for VFR flight rules. Great. Let's say you got out of the clouds, but as soon as you got out, the cloud layer below you has become overcast and you cannot see the ground anymore. It's time to do some loss procedures and probably communicate with Flight Watch to get an update on the weather. Let's perform some loss procedures now. Let's circle with a standard rate turn. Let's conserve our fuel down to 2,000 RPM. Cross-check and calibrate your instruments. If they can't get any good signals, you can climb. And you can communicate on 122.0 Flight Watch to get some updated weather, or you can contact your local ATC. Your local ATC can help identify where you are by asking you to ident and giving your general location. And then they can perhaps give you radar vectors to a better location. One way to find your local ATC is by looking for a little white box like this that says Contact Boston Approach, for example, on 124.9. Here's one that says 125.05 if you're around that sector. You can also whip out your airport facility directory in your region. Of course, make sure you're using the up-to-date version. And look up an airport near your location and look for this. The letter R with a circle around it. That means that on this frequency of 124.4, that provides radar coverage and services. Remember, radar services and coverage are usually based on a minimum altitude, so be sure that you're high enough to get this frequency and so that they can see you. Okay, let's use the same scenario from earlier slides, and we found our location using the Lebanon VOR and the Rutland VOR. Great. Now, since we've had some trouble with weather today, let's communicate on 122.0 Flight Watch and get an update on the weather. Let's say we contact Flight Watch and they tell us that Glen Falls is the nearest airport that has clear VFR conditions, or at least conditions that we can get to the airport safely in. Great. Now let's talk about how we can divert to that airport and what we need to do. If your diversion is due to an emergency, for example, low fuel, or you have a sick passenger, or an airplane problem, then you're going to want to get to your diversion airport as soon as possible. So if we're flying to Glen Falls, then we want to get there right away. So I'm going to use some rules of thumb to get there. First of all, let's talk about our course. Straight line course there. Looks like it'll be on about a westerly heading. If this was close to my true course, then that would be 270. Add variation, which we know is around 15 degrees at this point in this sector, which would be about 285. degrees for a magnetic course. So I'm going to go ahead and turn about 285 degrees. I could also use a straight edge and find a nearby VOR, use the straight edge to parallel my course and find that on the VOR it's about 280 degrees. Look at that, or 285 degrees. So that worked out about right. Now I know the maximum elevation figures here show me around 4,200 and 4,300. Since I'm traveling west, and I know it's even 1,000 plus 500, then it looks like 6,500 should be fine to clear all my obstacles. And it looks like around here, halfway through, I can start descending more and more. If I want to use a rule of thumb for distance, I know that the VOR radius on the sectional map is about 10 miles. So I can use a finger's width worth here, keep my fingers the same width apart. There's 10, 20, 30 miles. So it's about 30 miles to Glen Falls from our current position. As for the estimated time en route or arrival, then you can go ahead and use your E6B, flip it over, just use the last winds aloft if you don't have a whole lot of time, and you can use your computation now based on the about 270 degrees off, a little bit less than that for your true course, and then you can find your ground speed, wind correction angle, and so on by just using the data you've already figured out from your flight plan. So if we were to figure out a diversion the long way, here's what we'd do. First, draw a line from your current position directly to your diversion airport. Next, you're going to measure that distance. I think it's acceptable to be using rules of thumb during this part of your flight as well, because while you're circling during this, you're going to want to be able to look out the window as well and keep a lookout for traffic. See and avoid. You're welcome to try to figure out your true course by measuring your course in relationship to one of the bars on the map. However, it's just as acceptable to find parallel courses that already exist on the airways, and then figure out your actual magnetic heading that way as well. If you got an update on the winds aloft through FlightWatch, then you can plot that on your E6B and then get a wind correction angle. That'll of course give you your ground speed as well, and a magnetic heading that you'll be using. With the ground speed, you should be able to quickly find your time that it will take you to get to that point through your measurement, and then get an estimated time en route and an estimated time of arrival. Make sure before you depart your point that you mark the time. Now that you have some time, you can get how much fuel that will burn. If your diversion airport is a ways away, you're going to want to figure out all this information before you start heading that route, especially if it's not quite an emergency. Now you can make a plan, start figuring out that wire checklist, and remember, always use your resources. If you have a GPS that's functional and has an updated map, always check your calculations to that GPS or any other reliable navigation system. And like we said in the beginning, if your diversion airport has a VOR on the field or nearby, like Glen Falls, then why not go ahead and start flying directly towards that VOR after you've tuned and idented and check for your maximum elevation figures. Then you can work on the computations on the way there. Just make sure you know your time before you head off to your diversion airport.